forging ahead in Unit 2, which is all about exponent expressions. I preempted this before we started recording by saying that this is going to be new for pretty much all of you. Okay, and so keeping up, asking questions, doing your homework, it's going to be very, very important to success in Unit 2. And the objective for today is I can write and evaluate expressions with exponents in standard and expanded form. Okay, and so just kind of talking about what an exponent expression is. What is a power? Okay, struggle. Okay, fine. What is a power? What does it look like? What does it do? Also call it an exponent. We've used it in PERMDAS before. But what does it look like? What does it do? Oh. Okay. Yeah.
You have to like multiply the number by itself, like of the amount of the number it says.
Okay, so if you had something like, let's say, 6 to the 4th power, that doesn't mean 6 times 4, does it? No. What does it mean, though?
6 times 6, 4 times.
6 times 6 times 6 times 6. Okay? 4 6s all being multiplied together. And where this comes from is, think back to like when you first started learning about, well, counting and math and first grade, second grade, you learned how to add. And let's say you had 4 plus 4 plus 4 plus 4 plus 4. Okay, you'd be like 4, 8, 12, 16, 20. Okay, well, when early mathematicians were kind of developing operations and symbols and things like that, they realized, this is a lot to write out. There's got to be a faster way. And thus we had multiplication, right? Multiplication is just repeated addition. How many 4s you have being added together? 5 of them. That's the same as 4 times 5. Okay? And exponents are kind of the same thing. Here's the definition that I want you to take away. Exponents and powers, what they are is they show repeated multiplication. Right? Rather than writing 4 plus 4 plus 4 plus 4 plus 4, we multiply 4 times 5. Rather than writing 6 times 6 times 6 times 6, we use exponents to write it as 6 to the 4th. It's just a simplified, more straightforward, less messy way to write multiplying by the same thing. And you can also multiply or use powers with variables, right? If we had n cubed, what does n cubed mean? Really? A number cubed, sure, we don't know what it is, but by cubing n, what does that look like? What does it mean? Yeah. N times n times n. Good. Rather than writing n times n times n, we use the power n cubed. Okay? And the base, here's our first definition here. The base is a number or variable that is attached to the power. It's a number or variable that is attached to the power. It's what's being multiplied over and over again. Okay? So in our above examples here, in 6 to the 4th, 4 is the exponent, the power. What is the base? 6. In n cubed, 3 is the power, the exponent. What is the base? N. Okay? It's whatever is attached to the power. It can be a number. It can also be a variable. Okay? The coefficients, like we've seen with coefficients with equations, we've already seen this word pop up before, but is a number that comes before a base. And here's the kicker about a coefficient. It is not affected by the power. Okay, it is not affected by the power. We'll talk about why that is in just a little bit. But the coefficient is a number that comes before a base. It is not affected by the power. So let's just go down to that 2n to the fifth one, that first one out of the happy pencil there. We can see the exponent is 5, and actually when we do this work, we'll have to underline each part. So we'll do the coefficient in red, the base in green, and the exponent in blue. We can see the exponent here is 5, okay? The n is what's attached to the power. That's going to be the base. In this case, we have that 2 out in front. That's our coefficient, right? And it said the coefficient is not affected by the power, which means when we go ahead and write this in expanded form, and I'll do it again with 2n to the fifth here, like we did with 6 to the fourth, expanded form 6 times 6 times 6 times 6, like we did with n cubed, expanded form n times n times n. For 2n to the fifth, how many 2's are being multiplied together? How many 2's are there in expanded form of 2n to the fifth?
5.
Remembering that, the coefficient is not affected by the power.
1.
Just 1. Okay? In expanded form, this is 2 times n times n times n times n times n. There are 5 n's all being multiplied together, yes, because that's the base, that's attached to the power. That 2, a coefficient out in front, it's not affected by it. And who can tell me why? Why would the 2 not be affected by the exponent 5? What operation is between the 2 and the n? So we could rewrite this to be 2 times n to the fifth. According to the order of operations, what has to be done first? The power over the multiplying? The power, right? So the n to the fifth is kind of its own thing in the sense that there are 5 n's there, but there are not 5 2's because this has to happen before we multiply by 2. That's why there's only 1. Okay? Like we talked about, everything goes back to the order of operations, it seems. Right? That's the basic laws of how we compute, how we calculate. Questions on the definitions? You've heard some of these words before, maybe not all of them, okay? But our goal today is, given an exponent expression, identify each of these things, power, base, coefficient, and then write it out in expanded form, right? So let's look again with 2 to the fifth, exactly what you're going to need to do. You might not have all the fancy colors that I have up here. So if you want to underline the coefficient and put a circle around the base, put a box around the power, whatever you want to do is fine, okay? But we're going to be identifying, or you can write them out too. You can say coefficient is, base is, power is, but we're going to identify what each part of this expression is, which we've already done with 2 to the fifth. So that one gets our blue underline, n gets the green underline, and then we have 2 gets the red one there. The coefficient is 2, the n is the base, and 5 is the power. Now, writing this in expanded form, we said there's only 1 2. We talked about why. And there are 5 n's all being multiplied together. Okay? The last part of our directions say evaluate the term when n is 2. There's not an n in every expression up here. Most of them, but not all of them. But when you have one, I want you to plug 2 in for n and then evaluate it. So for this one, we have our coefficient 2 here, but then everywhere we have an n, we're going to plug in a 2. Right? So it says n equals 2. And what is 2 times 2 times 2 times 2 times 2 times 2? Who's got the quick maths here? 64. Good. Okay? So you're identifying the parts, you're writing it in expanded form, and then you are evaluating. If there's a variable, you're plugging 2 in for n and using that to solve. So the next one, my coefficient first. What's my coefficient in negative 10n cubed? Josie, negative 10. What's my base in negative 10 n cubed? My base. N is the base, yep. And then the only thing left is the exponent, is the power, and that's going to be a 3 there. Okay. In expanded form, what's this going to look like? How many n's are being multiplied together? How many negative 10s do we have? What is this going to look like? Yeah.
Negative 10 times n times n.
Good. Negative 10 times n times n times n. Again, only one coefficient. Only one negative 10, and then 3 n's all being multiplied. Now, we go and we plug in 2 for n, because it says when you have an n, I'm giving you a value of 2. And what do we get here? What is the value of negative 10 times 2 times 2 times 2? Yeah, negative 80. Okay? So far, so good? Anthony, good? All right. The next one, 3 to the 4th there. Zoe. Zoe, what is our exponent in 3 to the 4th?
4.
It is the 4th. Is that 3 a coefficient or a base? Am I underlining that in red or in green? Which one is it, Josie? It is a base, okay? It's attached to the power. Remember that sometimes a base can be a number also. And in this case, you know, we're out of things underlined. Do we have a coefficient? No. You won't always, right? And so for this one, 3 to the 4th power, it is saying in expanded form, 3 times 3 times 3 times 3. Okay? Which equals what? Yeah. And how'd you get that?
I did 3 times 3 times 3 times 3.
So you multiply, did you use a calculator? Okay, so you can type it in, just 3 times 3 times 3 times 3. Your calculator can do that for you. What are some strats that you might have to be able to do it mentally? You could just still do 3 times 3 times 3 times 3, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. Anyone else have any other thoughts? Yeah.
Can you do like 3 times 3 is 9 and the other 3 is 9?
Yeah. Remember, you can multiply things in any order. So what you might want to do is multiply the first 2 3's together and the second 2 3's together, but separately, to get 9 times 9, which is a more mental fact than 27 times 3 would be. Okay? So either way works. You will be able to use a calculator on the test. Okay? But just remember that, you know, you are able to multiply things in any order. Okay? The next one now, we've got some parentheses. And so when we look at this, we have an exponent of 2. And what is the base of that exponent of 2? What is being squared? Dominic.
N to the power 3.
Yeah, everything inside of our parentheses. Okay? Parentheses in this case are kind of used to expand a base. We'll see that even more when we do 6n cubed here. But really what this is saying, because I'll underline this is our base here, the whole thing, even the power. Because really what this is saying is that we have 1n cubed and we're squaring it. Right? The base of that power of 2 is n cubed, which means we have n cubed times itself. Even further expanded form, girls, I love that you're working, but okay? Even further, each n cubed is an n times an n times an n. Right? We have n cubed squared that we start with here. We start expanding that by saying what's being squared, the n cubed is. So that brings us down to n cubed times n cubed, something times itself. And then going even further, each one of those n cubes is an n times an n times an n. So all told, we have 6 n's being multiplied together. So that when we plug in our 2 for each of those n's, it looks very similar to what we have over here, right? We already have what 6 2's are, total that is 64. Okay? So let's jump down to that 6n cubed in the second row there. What's our exponent in 6n, that quantity cubed? Zoe? The 3. What is the base? What is being cubed? Mia? The 6, just the 6? The 6 and the n. Again, those parentheses kind of expand the base. That 6 is not a coefficient to our power of 3. When we write this in expanded form, we do have 6n times another 6n times another 6n. There are 3 of them there. Different from what we had up here, right? Without parentheses, 1, 2. The 2 is a coefficient. With parentheses, there are 3 6's, just like there are 3 n's, because that 6 is part of the base. And the difference is the use of parentheses. Right? So now, further expanded form, we're going to be plugging in a 2 in for each of those n's. So we have 6 times 2 times 6 times 2 times 6 times 2. All told, what does that end up equaling? Yes, Zoe? 1,728. Okay. Questions on any of this? Yeah.
Can we do the last one?
The last one? Yeah. So these kind of go hand in hand here because they're very similar, except one's got parentheses, the other one doesn't. Right? So let's start with the one without parentheses first. Let's run through our labeling here. What's our exponent? Josie? 4. And 4 is the power here also, right? What's our base in the first one? Nolan?
Base in the first one, it's
Just
negative.
Nope, you were correct the first time. Just the n. The reason why the negative sign is not included is because if you saw this last unit with equations, just a negative n by itself, and I said, what's the coefficient? What would you tell me the coefficient was? What's the number that comes before the n there? What? Negative. No, coefficient's a number.
1.
Negative 1. Okay, this term right here is the same as saying negative 1 n to the 4th. Okay? Without parentheses, the negative sign is not part of the base. Our coefficient is technically a negative 1. So in expanded form, there's only one negative sign, and then 4 n's all being multiplied together. Negative 1 times n times n times n times n. Whereas in the second one, where that negative sign is in parentheses, what's the base of that power of 4? The negative sign in parentheses, that's the only difference between these two here, is that one's got parentheses, the other one doesn't. When in parentheses, the negative n in parentheses, what's the base of that 4?
2.
Negative n, right? The whole thing's the base. So that when we write this one out in expanded form, this one is going to have a negative n times another negative n times another negative n times another negative n. There are 4 of them. 4 negative signs versus just 1 in the first one. And the difference is because of those parentheses. So in this one, negative 1 times 2 times 2 times 2 times 2. What does that equal?
16.
Negative 16, because we got that one sign there, right? In the second one, each n has a negative sign, which means each 2 has a negative sign. What's negative 2 times negative 2 times negative 2 times negative 2? Positive 16. Okay? A difference of 32. And all we did was put those parentheses there. Okay? No, you must do all of it, Zoe.
What? No, that's for the other games. Do you have to do that?
Yes. Your homework for tomorrow is the second page. We've got some time to do some now. It's the same thing that we were doing here. What is the power? What is the base? What is the coefficient? Write it in expanded form and then evaluate it. On the second page, you do have both an n variable and a y. Each one has its own value. So I think n is 2 and y is 3. So just pay attention to which variable you have. Okay. But let's take one from the top 2 rows there. Let's kind of go section by section. Top 2 rows. What's one you'd like to do together? Anybody? Okay, second 2 rows. Any you want to do together here? And your directions are the same as you had in the first page. Yeah.
So like 10y over 2y.
Ooh, for sure. 10y to the 4th over 5n to the 5th. Okay? What are our exponents here? And there are 2 of them. Josie? 4 and 5. Okay? What are the bases here? And again, there are 2 of them. N and y. And what are the coefficients here? And again, there are 2 of them. Anybody? The 10 and the 5. The fact that it's a fraction doesn't really change much for expanded form. We can see in the numerator we have 10y to the 4th, which in expanded form looks like what? No parentheses, 10y to the 4th. What is that in expanded form?
10 times y 4.
Right. Only one 10, and then times y, times y, times y, times y. Then the fact that it's a fraction just means that we're going to put a fraction bar in there. That's it. Nothing fancy. In our denominator, what's 5n to the 5th written out in expanded form? Yeah.
5 times n times n times n times n times n.
Right. Again, only one 5, because there are no parentheses linking the coefficient to the base. And then we have 5 n's. N times n times n times n times n. So now when we write this out, plugging in our variables, we have a 10 and y is 3. So 3 times 3 times 3 times 3. And then in the denominator, we have 5, and then 2 times 2 times 2 times 2 times 2. What do we get? What's 10 times 3 times 3 times 3 times 3? Yeah.
810.
810? What is 5 times 2 times 2 times 2 times 2 times 2?
460.
Can we simplify this at all? Because it is a fraction, so we have to ask, can 810 over 160 be simplified? How? And how do we know?
Did you get the bottom?
By what?
By 2?
By 2, also by,
4. Wait.
not 4. By 5, also by 10. They both end in 0, right? The whole 0 trick, when you've got a fraction, if they both end in a 0, those zeros just cancel out, which mathematically means we are dividing by 10, okay? If they both end in a 0, they cancel out. Your final answer is 81 over 16. And that can't be simplified any further. Okay? So, trust expanded form. Hopefully you see that, that was kind of an intimidating fraction to start with, but ultimately not that bad. Okay? And you break it all the way down. Questions on what you are supposed to do? Alrighty. This is due tomorrow. That's how you math.
You have to like and subscribe.